And last for 3.1, region bounded by two curves. Region bounded by two curves means either involve curve and curve or line and curve. Okay, we look at the first region. We have curve and curve. So, formula to find the area, we just integrate from A to B and we take y1 minus y2. We take curve on the above minus with curve on the below. Okay, second region, same. We take y1 minus y2 since the line above y2. So, y1 minus y2. We look at the region. We go to example 3a. Find the region bounded by the curve y equals to x minus 1 squared plus 3 and y equals to 7 from x equals to negative 1 to x equals to 3. To find the region, we need to sketch the graph. We have quadratic function. And this one is positive x squared, so minimum point. Since our function in completing the square, so we just take value for x inside the bracket. So we have x minus 1 equals to 0. Then we have x equals to 1. And outside the bracket is value for y. Y equals to 3. So our minimum point is 1, 3. Then we find the intercept. X, y. When x equals to 0, we get y equals to 4. And when y equals to 0, we can solve value for x. So we have 1 intercept. Then we sketch the graph. We put minimum point 1, 3 and sketch the smile graph. Put the intercept when x equals to 0, y equals to 4. Y equals to 7. We try find when x equals to negative 1. We get y equals to 7. And if we put x equals to 3, we also get y equals to 7. X equals to negative 1 here. And x equals to 3 here. So this one x equals to negative 1. X equals to 3. Okay, we want to find the region bounded by curve. This one curve. Y equals to 7. This one. X equals to negative 1 and x equals to 3. Okay, so our region here. Okay, and now we find the area. We integrate from negative 1 to 3. Okay, y equals to 7 minus with y equals to x minus 1 square plus 3 dx. We take above minus below. So above is y equals to 7 and below is quadratic function. Then we simplify negative 1 until 3. 7 minus, we expand x squared minus 2x plus 1 plus 3. Then we simplify again. We get 3 minus x squared plus 2x dx. We integrate. We get 3x minus x cubed over 3 plus 2x squared over 2. Negative 1 until 3. We substitute value negative 1 and 3. Then we calculate. We get answer 32 over 3 unit square. Example 3b. Given a curve y equals to x times with 4 minus x and line y equals to 2x minus 3. Curve and line. Okay, first find the coordinates of the points of intersection of the line and the curve. Okay, we have curve y equals to x times with 4 minus x and line y equals to 2x minus 3. Both are y, so expand for x minus x squared. Same is 2x minus 3. Then we solve, we arrange x squared minus 2x minus 3 equals to 0. We factorize. Then we get x equals to -1, x equals to 3. We want to find intersection point. So we need to substitute x equals to -1 to any function, quadratic or linear. Okay, so I choose linear. So substitute x equals to -1 into linear function. Then solve, we get -5. And next, when x equals to 3, substitute, then we get 3. So we conclude points of intersection are -1, -5, and 3, 3. We continue same question, but now we want to sketch both graph on the same coordinate axis. Okay, we have quadratic and linear. We have y equals to x times with 4 minus x. We expand, we get negative x squared plus 4x. And we have line 2x minus 3. Okay, we start sketch graph for quadratic. Since this one is negative x squared, so we have maximum point. So x equals to negative b over 2a, negative 4 over 2 times -1. So we get answer 2. Then we find y. We substitute 2 into x, so we get 2. 4 minus 2. Then we get 4. So our maximum point is 2, 4. Then we find the intercept. When x equals to 0, we get y also equals to 0. When y equals to 0, we have x factorized, we get 0 and 4. Okay, for linear, we direct find intercept. We know this one is positive, so graph like this one. Then we find the intercept, xy. When x equals to 0, y -3, and y equals to 0, x we get 3 over 2. Okay, now we sketch both function on the same coordinate axis. Quadratic, we have maximum point 2, 4. So the graph touch 0, 0. So set 0 and intercept is 4. Okay, next we sketch graph for linear. We have intercept 0, -3, and 0, 3 over 2. So this one -3, and this one 3 over 2. This one graph for y equals to x, 4 minus x, quadratic. And this one graph for linear, 2x minus 3. Okay, finish. Sketch both graph. Still same question. Now we want to find the area of the region enclosed by the line and the curve. Okay, now we find the region enclosed first. So here, region enclosed by curve and line. So to find area, integrate from intersection point, we have -1, x equals to -1, and x equals to 3. Answer we get from 3b1. First question. So we integrate from -1 until 3. We take quadratic. Quadratic is x, 4 minus x, and minus with line 2x minus 3. Why we take quadratic minus line? Since the upper is quadratic and below is linear. So quadratic minus linear. Then we simplify. We get 4x minus x squared minus 2x plus 3. Simplify again. We get negative x squared plus 2x plus 3. Then we integrate. We get negative x cubed over 3 plus 2x squared over 2 plus with 3x. Integrate from negative 1 to 3. Okay, then we substitute value, simplify, substitute 3 first, then minus with negative 1, substitute negative 1, then we calculate, we get answer 2 over 3 unit square. We continue question 3c. Given two curve fx equals to x squared plus 2 and gx equals to negative 2x squared plus 5. Question asks to find the region bounded by the graph of two functions in the first quadrant. So this one is smile graph. Smile graph where we have minimum point. We get minimum point 0, 2. Okay, then we find the intercept. xy, when x equals to 0, we get y equals to 2, and when y equals to 0, x cannot be solved, so no value for x. Okay, first graph. Second graph, we have negative 2x squared plus 5. Negative 2x squared quadratic, but set. So we find maximum point. Maximum point is 0, 5. Then we find the intercept. xy, when x equals to 0, then we get value y 5. And when y equals to 0, we get plus minus square root of 5 over 2. Okay, then we sketch the graph. Both graph in same coordinates. Graph fx, we have minimum point 0, 2. So at 0, 2, graph smile here. Graph gx, we have maximum point 0, 5. So we sketch set on point 0, 5. So region bounded here. We need to find intersection point between two curve. This one. What's value for x? So we equal fx equals to gx. Then we solve. So we have 3x squared equals to 3. X squared equals to 1. X equals to plus minus 1. So this one negative 1 and this one 1. We want to find the region bounded by the graph of two functions in the first quadrant only. This side. To find the area, we integrate from 0 to 1. Since we want on the first quadrant only. So 0 until 1. Above minus below. So above is gx and below is fx. So gx minus fx. So function gx, we minus with fx. Then we substitute. Gx is negative 2x squared plus 5. We minus with fx, x squared minus 2 dx. Then we simplify. We get negative 3x squared plus 3. Then we integrate. We get negative 3x cubed over 3 plus 3x from 0 to 1. Then we simplify. We get negative x cubed plus 3x 0 to 1. Then we substitute value 1 and 0. So we get negative 1 cubed minus 0. Then we solve. We get 2 unit square.